All right.
You didn't get to listen to the choir sing today.
Oh, I know. I'm coming Thursday night, though, I think.
I probably will.
I got driver's ed 3 times this week.
Very nice. Okay, let's focus on math today. Shh. Hadassah. Shh. And I need... Woo, Principal Frederick. I need Tayson to read this first paragraph.
Okay. Travis and Tahani.
Excellent. Yep, nailed it.
Construct the image of rotation when given the center and angle of rotation, but today have encountered a different issue. How do you find the center of rotation when a rotated image and its pre-image are given? They decided to explore the idea with their friends Carlos and Clarita.
Very nice. Thanks
These
for...
the same Carlos and Clarita.
Apparently.
I think that it's different people every
A
day.
group of like 4 of these.
Group of mathematical
Like, let's be
nerds.
honest, they're their only friends.
Okay. So...
At least I have friends.
Shh. Will, be nice. Go ahead and read the second paragraph for me too, Will.
Alrighty. Each pair of friends creates a puzzle. Why did they put puzzle in parentheses? Not parentheses, quotes.
I don't know.
Anyway, for the other pair, by sketching a drawing on a graph paper in which a rotation of a figure is shown, but the center of rotation is not marked. The other pair has to figure out where the center of rotation is located. Here's the puzzles they created for each other.
Okay. So, what we need to do is, we're actually going to continue reading. Look at this puzzle. What are we trying to really find here, or what are they really trying to find?
The center of rotation.
Yeah, what's another way to say that?
The center of your circle or something?
Okay, so the center of a circle that would be made
With both points on its circumference? I don't know.
with both points on its circumference. That's a great way to say it, yeah. Or in the triangle's case, with all 3 points, they wouldn't be on the same circumference, right? But with all 3 points on the circumference of concentric circles is what we would say there. Okay, so circles that are have the same center point. That's what concentric means. Like, it's almost like a mixture of Spanish, like concenter, right? Concentric, like with the same center. Get it? It's right? Yeah?
Sure.
It's a stretch, but we're doing our best. Carlos and Clarita think that the puzzle they have been given is too easy since it's only a single pair of rotated points and it's pre-image right there. Okay? All right. Let's see. Jacob, I want you to be Carlos. Hadassah, I want you to be Clarita. Let's see. Mia, I want you to be Tahani. And Travis doesn't say anything. Okay, Carlos.
The center of rotation is at the midpoint 2-4, halfway between the image and pre-image points, and the point has been rotated 180 degrees.
Very good. Let's pause for just a second. I need your motivation to be like, you've had a really long night of just studying for finals, and your new motivation is like, you are here, and you are like, okay, I'm using all of my brain power for this.
What? So Alan.
Who's Alan? Yes. Oh, from the play. Yes. Exactly. I'm sorry. I didn't catch names. This is a play. All right. Anyway. Okay. That's your motivation. You got it? Okay, Clarita. Nope, you're not going yet. But your motivation, because Carlos has to go again with that motivation. Your motivation is that you just saw the cutest puppy in the world and you're really excited about it. Okay. Tahani, your motivation is that you just got done scaling Mount Everest, so you're like super adventurous, but also pretty out of breath. Okay? All right? Everyone got their motivations? And action!
The center of rotation is at the midpoint 2-4, halfway between the image and pre-image points, and the point has been rotated 180 degrees.
Very nice. Clarita, though,
The center
disagrees.
of rotation is at the point 0, 0. Since both the image and pre-image points are 5 units away from the origin, I'll need to use the protractor to find the angle of rotation.
That puppy was so cute. That was perfect, Tahani. Keep going.
Go.
Yes. Tehani says.
Both wrong. Don't use either 2, 4, or 0, 0 as the center of rotation when you complete this puzzle.
Very nice. Out of breath. Yeah, good. All right, Carlos.
I can see how both of our points can be in the center of rotation, but now I think that with a single image and pre-image pair of points, any point can be the center of rotation.
Okay. So do we know anything of what just was said? No? Okay, awesome. So you guys did great acting, but now let's get the holistic picture. That's why the director is here, right? To give you some context. Yeah, and see. Very nice. Okay, so Carlos said that he and Clarita, as they're looking at this, Carlos thinks it's the point 2, 4. So he's saying, I think this point of rotation is aquí. Okay? Kind of makes sense. It looks like it could be, right?
Yeah.
So that's what Carlos thinks, but Clarita's like, hold up. I think it's at 0, 0. Since they're both 5 units away from that origin. How did she know? It's easy to see that A prime is 5 units away. How did she know that A is 5 units away?
It's a 3, 4, 5 triangle.
Oh, it is a special right triangle. Let me try that again. Triangle that again. Yeah, because there are 3 on this side. Bruh. 3 on this side, 4 on this side. So that means that the hypotenuse must be 5. Do you guys remember that? What that's called? Don't say it. What's it called?
Pythagorean triple.
Yeah, Pythagorean triple. Very good. So that is one of those memorized Pythagorean triples.
Triangle.
What?
It's called triangle.
Oh my gosh. Okay. So she thinks that because they're both 5 and 5 away, she thinks that's the center of rotation. Okay. Carlos thought it was because it's just right in the middle, and it's kind of like diagonal, the same distance basically, right? Not exactly diagonal, but they've got the same distance over, right? Because they make triangles with 1, 2, and then this would be something. We could figure it out if we wanted to. Yeah, they've got the same rise and run. Very good. So that's what Carlos is kind of thinking.
Okay, so here's the thing, right? So the center of rotation, as long as they're both in equal distance from both points, then they're part of the same circle.
Oh.
Which means that there's probably, if you take the rise or run, you can make those 2 points a line, and I'm half certain that any point on that line can be used as center of rotation.
Really? So if we went from here, actually, I've got a ruler.
A ruler. Ooh.
Why is it like accidentally so annoying?
I don't know.
You know, I was gonna use a ruler in art, but then I was too lazy to. So my cube looks funny.
Why would you need a ruler? You're using wire that's crazy bendable.
Okay, so here we go. Here's this line, right? This is what Tayson just hypothesized, that any point along this line,
Would it be a hypothesis or a postulate?
probably the way you set it up, postulate.
Okay.
Good distinction, thank you. Important conversation, I'm glad we're having it. So he is postulating that any point along this line could be the center of rotation, okay? Because any point along this line will be the same distance. Now, this actually kind of reminds me of a proof that we did once upon a time where we had a line segment between 2 points and a perpendicular bisector, which means it was perpendicular and these were the same. And we made a proof that said any point C along that line will be equidistant from both of those other points.
Wow.
Right? So that this would be X and X. Or this would be Y and Y. Right? They would be the same distance away. Okay?
It's a spaceship.
It is a spaceship. Spaceship's gone. Okay, so we did a proof that states that, right? So you guys are do you kind of remember that proof from a couple of, gosh, it's been a minute. I can't even remember when it was.
A long time. I think it was the first. No, it was early
No.
second.
Yeah. But we did prove that, right? That any point along the perpendicular bisector will be equidistant from the endpoints. Okay?
AKA Clarita is incorrect.
Well, but is she? Because this is on that line, isn't it?
So then they're both correct?
So then they're both seemingly correct, aren't they?
It's like
Okay, so that's good information. So now what we need to do is find at least 3 additional points that could be considered, the center of rotation. So what's another point that might be a center of rotation?
4,
Eight.
6.
Okay, 4, 6. There's a good one. Could like 4 be one? This point right here. Could that be one?
No.
What necessity?
It has to be on that line.
No. It has. Does it have to be on the line? That's kind of what I'm asking. Jacob?
Yeah.
I don't think you have the points in that spot, or I'm just counting wrong.
What?
Because it says 4, 6, but I think it looks like you have it on 3, 6, not 4, 6.
You were right.
He is on
So it should be 3, 6.
Yeah, he is on 3, 6. Oh, Mr. Ball.
My brain was hurting so much. I was like, why is?
Good distinction. And then this one should be then 3, 4. So we don't think 3, 4 could be, right? Because 3, 4 is only one diagonal block away, and then it's actually like 3 horizontal and 1 vertical away from A prime. So that would not fall in the circumference of the same circle, right? Yeah. Good. So I think that what we're kind of designating then is it has to be a point along this line.
What I'm assuming is how you find that is you just like draw the points between those two, A and A prime, and then like find whatever like the midpoint of that is basically, and then draw like a
Yeah. So there's actually a way that we can do that too.
Because you'd just be finding perpendicular bisector.
Yeah, and we can construct a perpendicular bisector using our compasses, right? So this is a great application for how we could do that. Okay, so before we continue, we have the perpendicular bisector already drawn here. So let's go ahead and just find 2 more points. We found 3, 6 already. Oops. What are 2 more points along this line?
The 4, 8.
Along the line, well, I mean, 1, 2.
Yeah, very good. 1, 2,
Let's go.
and 4, 8 is another one as well. If you really wanted to get jiggy with it, you could also say like
40, 80, or
1.5, comma 3.
Oh, that's a big number.
that's a jiggy with it.
Tayson, that's a pretty big number.
Okay.
1.5.
Oh my gosh.
Bro, I can't even count to that.
Okay. So there are some other options, right? Okay, how about... So the justification then, sorry, number 1, the justification would be what?
I don't know, any points on a line would be equidistant from like the 2 points, and therefore they would be part of circumference on the same circle, and that's what a reflection is? I don't know.
Yes, or rotation. But what line was it? What was the specific line that we called it?
Perpendicular bisector?
Any points on the perpendicular bisector.
Let's just read from my head. I'm dying.
Equidistant is such a weird word.
Yeah. And could be the center of rotation. I'm also going to make a note that says we've proved this, or we've proven this previously. Because that's kind of a big statement to just make, but we actually have proven it. So we're going to go ahead and just acknowledge that.
That was a lot of cosine sine.
Amen, brother. So we kind of talked about this already, but what do you think about Carlos' last statement that any point could be the center of rotation? Yeah, Hadassah?
I disagree because it can't be any point. Like, any point can't just be, like, you can't just choose, like, a random point around it and be like, yeah, that's the center of rotation.
Yeah.
It has to be on the perpendicular bisector.
Yeah.
If it's not, then it's not going to be your center.
So then we would have to add a qualifier that says on the perpendicular bisector. Right? Then it would become true. But any point, we talked about 3, 4, right? That point was not equidistant. It wasn't on the perpendicular bisector, so it's not going to work. Very good. And in so doing, just by adding that on the perpendicular bisector and what we wrote under number 1, that answers the rest of number 2 as well.
Are we going to start with the frogs tomorrow?
That's my plan.
Let's go.
Sweet. For frogs aren't as fun as pigs, but frogs are still fun.
No. Sorry, my plan is Friday to start with the frogs.
Oh.
Tomorrow we're going to finish chapter 32. And then Thursday we can start with the frogs.
W.
You know, 2 L's make a W.
Yeah, but I said it now and he said a W, so.
Rotation, at least we're starting it this week. It could be next week. Like,
It's true.
It could be next.
All right, now examine the puzzle that Carlos and Clarita gave to Travis and Tahani, T-Rav, and find the center of rotation for this puzzle. Or if there could be more than one, describe how you could find all the centers. So that's this one. Now, I want to guide you and give you a little hint here. How can we use what we just used for the last one to help us in this one? Because now we don't just have one point we're dealing with.
I have a genius strat for you.
What's your genius strat?
What if we do all of the perpendicular bisectors, because they're at different slopes, right? But they're not parallel, which means they have to intersect.
Oh.
They all intersect at one point. That's probably the right point.
Yeah, I would say that. So let's try it. Because if they're all equidistant, right, they'll have to be equidistant from their perpendicular bisectors. So if all those perpendicular bisectors intersect at one point, that means they all have to be equidistant from that one point. Very good thinking. So there's a way that we can do that by using our compasses to construct. Okay, and I will go over that because I think that you have some constructions potentially, or you're going to have to, in some of these questions, use constructions rather than this other method I'm about to show you. But we can find the perpendicular bisector by using the opposite reciprocal of the slope. Okay, now I'll show you what I mean by that. What is the slope right now of b to b prime? Negative rise of 4 over a run of 2, what is a simpler way to say that?
-2.
Negative 2, right? Which I acknowledge is negative 2 over 1, yeah? The perpendicular bisector, or the perpendicular line to this line, will have the slope that is the opposite reciprocal. So that means opposite sign and the reciprocal of the number, okay? So perpendicular, Euler, is going to be positive. And then what is the reciprocal of 2? Positive 1/2, right? Because 2 is actually 2 over 1. So if I take the reciprocal of that, it's going to be positive 1 over 2. This is the perpendicular line to b over b prime, or b prime, excuse me. Okay? But now I also said that I need the perpendicular bisector, which means it has to be in the middle of that line. So what's the midpoint of b prime? Yeah, 4, 2, right? And I saw that by seeing that there's this run of 1, rise of -2, run of 1, rise of -2. So that actually just like shows me the midpoint, which is pretty nice. So I can just create a line through that point at 4, 2, with the slope of positive 1/2. So now I'm going to have a rise of 1, run of 2. Okay, so here's a point. I'll go in the other direction as well. Rise of 1, run of 2. And now I'm going to use a straight edge. Come on. To go ahead and connect those points. So that means that in theory, any point that falls along this line could be or is equidistant, not in theory, in proof, is equidistant from B and B prime. But I need the point that is equidistant from all of these vertices, not just that one, right? So let's do the next one. Let's do A to A prime. Do this one in red. What's the slope of this one?
This is a funny thing. It don't got one.
Yeah, it doesn't have one, right? It's just a horizontal line. So what kind of line will be perpendicular to this?
An undefined slope.
An undefined slope, which would be, what's another way we could say that?
Vertical.
Just a vertical line. Very good. And it needs to be at the center. So how can I find the center?
Well, we have a whole midpoint formula.
We do have a midpoint formula, so we could use that. You can also just count how many spaces there are and have it, right?
And believe it should be at maybe 2.5.
I would agree with that. And then it's just a vertical line, so I'm just going to get straight up and down. Ooh, it intersects with one spot already, so we see that. I do want us to do C to C prime just to be certain, since this is kind of our first taste of this. But if it works, then I'll say, or if it goes through that same point, then I'll go ahead and say, okay, we don't need all three. It's extraneous, or it's redundant if it works. But I want us to do it right now just to be certain. Okay. This one has a slope of, or a run of 1, 2, 3, 4.
And 10, I think.
And a rise of, 10 downward, which is a slope of negative 2/5. So that means that the middle point is going to be 2 over and 5 down from the original. So 1, 2, 1, 2, 3, 4, 5. Oh, look at that. That's nice. So that means the perpendicular the perpendicular line to this one will be the opposite reciprocal. What is the opposite reciprocal of negative 2/5?
Positive 5 halves. Or
Positive 5 halves. Very good. And it'll go through this point right here that we have determined is the midpoint. So I will go 1, 2, 3, 4, 5, and down 2. Ooh, look at that. It do go down. It do go down. Oops. Oops. My line's not straight. Yeah, you can see that it is 1, 2 is the center of rotation, because it is going to be, based off our work with perpendicular bisectors, it is the center of rotation of all of those individual points. So that means then that it's the center of rotation
Isn't it,
totally.
Isn't it 2, 1, isn't it? X, Y.
Oh my goodness.
I'm like,
Dyslexia. Ah.
there you go.
That was beautiful. Mr.
Thank
Ball.
you. Thanks, I've been practicing my song.
just like, yeah.
It's amazing.
Where all the words
I have
spelled wrong.
dyslexia.
Where are the words? Okay, very nice. So there's how we can use perpendicular bisectors. Now, again, but before we're done with all this, we will need to talk about how to construct perpendicular bisectors. So y'all got your compasses here today?
Mine's in my backpack.
Okay. So we will need those before too long. Jacob, you just flatly know.
No, I don't. Mine's broken. I'm
Okay.
What did you do?
I'll send you like an Amazon link or something and be like,
We were just gonna go to Walmart.
or that's even better. Just do it. Just do it.
Get the cheap ones.
If you have a dream, just do it. Anyway. So, how did we find the center of rotation for their puzzle?
Words, but like we connected all of them.
We found the perpendicular bisector of all the lines.
This was essentially
I
found all
can't freaking
possible
find the letter. Fell
centers of
out.
rotation for all of them.
So the lines that are created by corresponding points. So like line B to B prime, A to, or A prime, C prime. Okay. So this also will be a guide for you when you get to homework. Come back here and be like, oh, how do I do that? Oh, I know.
YouTube.
Okay. No, we've got a hot minute left. So we're going to illustrate and find the center of rotation of a figure of several image and pre-image pair points. If we make any claims, we're going to have to kind of provide a proof of those claims, okay? But before we do that, what we're going to do is we're going to go ahead and read through all of these vocabulary words, okay? Because these might be helpful for us as we continue on in this section and module of geometry, okay? Who would like to go first? Because we're just going to read through these.
All of them?
All of them.
Are we just reading the vocab?
Yep, and then I've got images drawn up here so that you can also kind of see these as well.
I shall go first.
Go for it.
Alright. Circle, the set of all points in a plane equal distance from a fixed point called the center of the circle.
So it looks like that. What is that distance called? We have a special name for it. The radius. Very good. Yes. So the radius is the distance from the center to the circumference. Okay? Very nice. Now concentric circles. Jacob.
A set of different circles that share the same center.
Very nice. So circles, those aren't exactly concentric, but the idea there, right? So if we were to draw all of the circles using a compass of these points, we would actually have a multitude of concentric circles. Okay, with the center being at 2, 1. You good?
I went to draw the next circle and I just look up and saw all the lines. And
Yeah.
my brain-
That's not a circle.
I was like, that's.
Okay. How about a chord? Psych, it's a chord. Tayson.
Like a musical chord or like a
Nope, circular chord.
oh,
A chord of a circle, rather.
chord of a circle is a line segment whose endpoints lie on a circle.
Okay, and a secant. Yeah.
A line that intersects a circle at exactly 2 points.
See? Can't. All right. Tangent.
Okay, a tangent is a line that intersects a circle at exactly 1 point.
No, it's opposite over adjacent.
It is also that, but not when we're talking necessarily about circles. So it's like something like this, right? It intersects only at that point right there.
Little itty bitty bit.
Planets.
That one. Boo boop boo doop boo doop boo doop boo doop.
Okay, planets go.
Boo doop boo 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 doo doo doo. Okay, how about a diameter? Just kidding, it's diameter.
Okay, a diameter. A chord that passes through the center of a circle.
There you go. So you notice how we're using some of the other vocabulary already. A chord is a a general case, but a diameter is a very specific chord. Goes through the center. Now a radius, Jacob.
A line segment with one endpoint at the center of the circle and the other endpoint on the circle. You want me to read the note?
Yes.
No, the word radius and diameter also are used to refer to the lengths of these segments.
Very good. So radius, if I ask for the radius, you could name that radius, but you also should name the distance if you know it, or the length.
Half the diameter.
Arc. Tesson.
A portion of a circle.
Yep, so that would be like that green bit along there.
Circle.
Yeah?
An angle whose vertex is at the center of a circle and whose sides pass through a pair of points on the circle.
Good. So this could be a central angle, or if you extended those lines as well, that can also be a central angle. And what we're referring to is that angle in the middle right here. That is the central angle. Harasa.
We're on
Inscribed angle.
an angle formed when two secant lines or a secant and tangent line intersect at a point on a circle.
So it could also be chords as well. But this is the inscribed angle. Okay? The intercepted arc now. Wilhelm.
Intercepted arc, the portion of a circle that lies between two lines, rays, or line segments that intersect the circle.
Yeah, so think about when we have two segments that are kind of hitting the circumference, that right there is the intercepted arc. Okay, it's just where they hit, and it's the space between them on the circumference. What? You look like you're about to say something smart.
No, my broken protractor made me jump. So I was spinning it around on my pencil and then it came flying at me and it
Only with you, Tayson.
Maybe that's why we don't spin protractors on our
No,
pencils.
It moved like 2 inches.
Oh my
And
goodness.
he got scared.
Okay, I would like you to take a couple of seconds just to make sure that you copy all these down so that you know what each one is, okay? What up, Jacob?
Every time you said Mia's name, you made me think of Winifred from, it's a Halloween movie. With the Sanderson sisters.
I don't know.
I can't think of the name.
Wait, no,
I can't think of the
no.
name.
Jacob, it's Hocus Pocus.
Thank
Oh,
you.
yeah.
I've never seen
I
it.
couldn't think of, I was like,
How could you not think of Hocus
Okay,
Pocus?
copy it down, copy it down.
You're done.
If you're done, great. Just sit quiet.
it was just like, sister.
It does just go flying at you.
Tayson, do you know what else comes flying at you?
Baseballs.
Yep, I was actually thinking baseballs.
Well, if we share a brain cell, like,
Yeah.
we're bound to be on the same plane.
Let me guess. To London.
What? Who would ever want to go to London?
That's a good point,
Thank
Tayson.
goodness. I would be here
Guess
for it.
Tayson, they got fish fingers and beans.
Yeah. I can think of a lot of places that have fish fingers and beans. You want to know what else they don't have? At least in America, you get
Ellen
chunks that are
Davis.
stabbed.
Not that I know.
It's quicker here.
Names to faces.
Oh.
Do you know what else they have there?
If I saw a picture, I
People.
probably would.
Not seasoning.
Maybe.
Facts,
They
bro.
conquered the majority of the world just to get no seasoning.
I know, British people stole all of the foods and then made them bland so they could claim it as their own.
And they still can't get a dentist.
Okay.
Hey,
Maybe.
don't be rude.
Bro, did you hear about that dude who got banned by the British Museum? And then, like, I can't remember why, he made a joke about them, right, because everything's stolen? Right.
Yeah.
Okay, is everyone done?
Yeah.
Dude replied to his ban
Awesome.
with the British Museum will take anything but a joke.
Okay, so describe the process for finding the center of rotation. How did we do it?
Okay, so well, for which one?
Yeah, what was the first step?
Well, first we found like the midpoint between two of the points.
Before we did that, what did we have to do?
Draw the line.
Yes, we had to draw the line, right? So first, draw a line between two corresponding points. So it's B and B prime, not A and B prime, right? So draw the line between two corresponding points, then find its midpoint.
Yeah.
Do you mean the reciprocal of the slope? Okay, so you can either...
I see a proof down there.
You can calculate the reciprocal of the slope for the perpendicular line. Okay. This is without using without using a compass also. So then find the reciprocal or the opposite reciprocal of the slope.
R-E-C. Wait, hold up. Allow me to spell. I'm bad at remembering how to spell things out loud. Hold up, I got it. R-E-C.
Does that help?
R. O. Yeah,
Yeah.
got it.
Yeah.
You're welcome. This is why spelling bees stressed me out, because I know how to spell things just fine. I'm an excellent speller.
They stress me out because no insect should be spelling. They have no business spelling.
Why?
I believe you
They
mean
stress
business.
me out.
Or business. What?
Revolve. You wanna know why they stress me out?
Why?
Because I'm really bad at spelling.
Fair enough.
You are really
Okay, then you have to draw the perpendicular line, right? And repeat that whole process for 2 more points. Or for another set of corresponding points. Repeat the process for another set of corresponding points. These shoes make a funny noise when I walk.
Squidward.
The golf team's gonna have fun if it rains down at wherever they are.
Yo, hey God, I don't ask for much, but if you could please make it rain. Thank you.
That would be a thunderstorming. That ball gets blown out of the sky by a lightning bolt, you know?
It's bad theology.
What do you mean? I'm not wishing that anybody dies or anything. It's your, like, you know.
And I'm just wishing a
All
thunderstorm.
right,
so
are you
cold-
finished writing?
I love
Okay,
Cold
that.
hits a ball
So
gets-
here's what we're going to do next then. I'm going to show you also how to construct. I'm going to remind you how to construct a perpendicular bisector. Does anyone remember offhand how to do that?
So you want to go to your endpoints and you want to draw 2 arcs that are a little longer than the halfway point, or at least, right? And then, so they need to be decently big. You might even just draw like a circle.
So a compass just has to be, it has to be larger than halfway. Okay. And then what do you do with those arcs? You
And then, so they'll intersect at 2 points, and you want to draw a line that intersects both of those points of intersection.
Then you draw an arc on the other side with the same distance, right? And then connect the points. Just like that. Ish. Doing it with a compass will actually make that exact. But it will create the perpendicular bisector, okay?
I did so well without the compass.
Okay. Remember though that you need to actually use a compass.
Yeah, I know. Well, I'm just proud of myself for getting yeah.
Good words.
No, I feel that. It's It's kind of like that equilateral triangle up there that I freehanded once. I was very proud of it.
And you're like, what was it, like 0.2 degrees or something?
It was 0.3 degrees off.
Oh, I was close.
I was also close. But I was proud of it, you know.
So you
Okay,
decided to-
so that's how you'll construct this. You will need to be able to construct these on your own, okay? So this is an alternative way to find those perpendicular bisectors. So instead of step like 3 that we just described, where we find the opposite reciprocal, sometimes it won't be a nice slope, so you won't be able to easily find an opposite reciprocal or a smooth midpoint.
Perpendicular bisectors are just the easy way to do it.
Yeah, like...
It's the most accurate.
Yeah, that's also true. This is the most accurate because you're drawing an exact point. Okay? Great. All right. Whew.
Yeah, he proves.
We are going to prove this.
You know, that's why if you're pressing hold, like one of the lines, you can press delete.
That's what this
Yeah,
is
but
built
it'll-
on.
No, it's only when you double tap it when it deletes everything.
All right.
Okay then. You do
Often
you.
Says-
that bothers me.
Prove the following.
Do we need to make the circle too?
There. Even fixed.
Probably.
Yep, you need to make this circle off to the side.
Can you zoom in on it, please?
We are going to need to prove that in a circular circle, the perpendicular bisector of a chord bisects the central angle formed by the radii drawn to the endpoints of the chord. Okay? So, OM is a perpendicular bisector of chord AC. And we have radii OA and OC. We're trying to say that this intersects this
Triangle
equally.
is free-handed.
That is gas. Very nice.
Never drawn a straighter line.
Sweet. Un, dos, tres, cuatro. Okay, anyway, El sonidito! Well, sounds like your prayer got answered, Tayson.
Wait,
At least it sounds like it's raining here.
it needs to be thundering. I need.
Okay, so here's what we're trying to prove up here in green writing also. That angle AOM is congruent to angle COM. Now, how can we prove triangle congruence? How can we prove angle congruence?
By using the triangle congruence.
By using triangle congruence, right?
You know,
Okay.
I got something else to add.
Is everybody done drawing or sketching this circle? You don't need to construct it.
But it has to be perfect.
It does not. It literally doesn't.
Fine.
Wait,
Thank
is
you.
The center one supposed to be O?
Yes, the
It was-
center.
I thought it was a D.
Brother.
So I was like, where'd O come from?
Oh, there you go.
No, it's so long.
Oh.
I don't like this.
Okay.
Suck it up.
It says you. You're such a
I finished before
perfectionist.
you.
Okay, so how could we prove this? Let's talk through the proof before we formalize it. We need triangle congruence first before we can make this claim of angle congruence. Tayson, what do you think? What's the one thing that we need?
Okay, so we need, I think the easiest way to do this would be to just have all the sides be equal, because that's
Okay.
right. So we have the AO and CO, they'd be equal because them's is both radiuses of the
Nice.
circle. So them's has to be, right? And then Are we given that OM is perpendicularly bisecting AC?
We are.
If we are, then AM and MC would be equal because that is the definition of a perpendicular bisector. And then OM is shared by both sides, so it's equal because it's the same line.
What is that property called? Do you remember?
The reflexive equality property.
Yeah.
Oh, oh, I get it.
If I put that on a test, will it be counted right?
Oh yeah. 100%.
You taking a screenshot of that?
No. My brightness is doing weird things, and I think this is what happened before my last iPad died.
Good to know.
How often do you restart it?
Not terribly often. Okay. So, hello, Pastor Dean.
Sorry. I have very important
Oh,
things
yes.
to do here.
I'm sorry that I didn't sign it yesterday.
You're right.
Sign it right there.
So
Okay.
signature there and so forth.
Okay. Thanks for bringing it over to me, and my apologies.
No, I just gotta
Get it done.
get it in.
Mr. Boy, your board keeps going in and out while away.
Yeah.
Oh, there it goes.
Oop, am I standing on something?
No, you're not. It's beneath this. Is this for men's only? Do we only have enough?
We're good on men's.
Okay.
The ladies and the co-ed, I don't know.
Okay. Let's see.
Yeah, we got chicken strips today.
Yeah, I know it's gonna be lit as long as they're crispy.
As long as it's good chicken strips,
Yeah.
it's gonna be good.
I should start bringing honey mustard.
Ooh, from Wendy's.
Oh yeah, their honey mustard's so good.
I mean, if Tim's in the good van.
I'm a chicken nugget expert.
Hey, can we get just?
Okay, there we go.
I remember when they first came
Just go to
out.
Jack's.
Thanks so much. No, thank you. All right.
A whole bag of.
So, what does that, by having three sides congruent, what does that tell us about these two triangles? That the triangles are congruent. Then we can use the fact that the triangles are congruent to say these two angles are congruent. Do you remember what property allows us to say that, or what kind of theorem?
By the way, Mr.
You
Boy,
separate the C's by paper towels. Yeah.
Can we have May's next week?
Come on.
It's May now?
Come
It's
on.
May next week, Tasty.
So let's go ahead and formalize this and start writing it down. So the first thing that we should always do when we're given a proof is what?
Do the given.
Word. Write the given, which is what?
AC, wait, no, oh,
The whole triangle.
hold on, it's the one thing's the perpendicular bisector, ain't it?
Perpendicular bisector. So we have perpendicular bisector OM
And AC,
of AC.
and AC is a chord.
So perpendicular bisector OM of chord AC. Let's say that. Of chord AC. Oh, perpendicular bisector OM, my bad. Of chord AC. What else do we have that's given?
That O's the center of the circle that AC's a part of.
Of circle O. And what else do we have?
The M's the like intersecty point or midpoint. I don't know.
Bisector OM is kind of denoting that. We could say midpoint M. Well, yeah, I think just saying bisector OM is good enough. But what else do we have? What else does the problem give us? Because notice I'm not just pulling these out of thin air, right? Where am I pulling it from?
Dense air.
The triangle graph theory we made, which I made from what? Thin air? Or dense air?
Ooh, nah, you made
No?
it from mediocre
Like-
air.
What did I make it from?
The words.
Yeah, the words, right? So what are the words saying about the last thing that's given to us in this circle? It'll help if you look at them. Bill, Hadessa.
You're missing a shit.
Radii. So with the circle O with radii what?
AO and OC
AO.
and CO.
Very nice. CO, it doesn't matter. Order of points in a line does not matter. Order of points in an array matters. So that's all that's given to us. So now let's start saying what Tayson had summarized for us earlier. I want a lot of the others of us to summarize this, okay? Tayson helped give us the framework. Now I want the rest of y'all to formalize it. So what could be a second step? Now there is no exact correct second step because we've got a lot of other things that we can say. So just take a shot at one.
Is this what Aiden feels?
Well, it's all written. It's all written down. Shh, it's all written down right here. So you just kind of have to make a statement based off of the things that we have here.
AM is perpendicular to CN? Or
A-
congruent?
Yes, congruent. Good. So AM is congruent to CM.
That is,
Why can we say that?
oh my gosh.
How do we know that they're congruent?
Because we got the lines there, you know.
Which line is it?
The perpendicular
That's
bisector.
what
If something is bisected, then that means that each side is congruent. So it's the definition of perpendicular bisector.
Definition, that's the word. I was
I was like, it's not a definition, is it?
Yeah.
remember the word definition. This is bad. I'm over here like, I really want to write and I've
That's
forgotten like
bugging
5
me.
words
Mm.
today.
The
That's what
bottom
online
left
sources
leg
are
has
for.
3 dashes and the top right one doesn't.
I mean, can we say something with O?
Because if one has dashes or
Yeah, what do we need to say with OC and what A? What is true about them? They are also congruent. So segment OC is congruent to segment OA. Why?
because of a right triangle something.
Not a right triangle something.
Your O's really do look like D's.
What are they?
Thank you.
Triangle
What are those two sides, OA and OC?
there. What's the word?
Maybe look back at the back page. Since we just went through all this, right? We just went through a whole bunch of vocabulary, so you can look back at that vocabulary. Also, Hadassah, you also can't say any more words.
What?
Because you already answered one, so you and
Oh.
Tayson
Okay.
are off limits now.
I mean, technically it's an arc.
You're
I was like,
Because
what?
Well-
I
it
didn't
kind
say
of cuts it
anything.
out. Technically.
AC is an arc. This is an arc right here.
Wasn't that what you're asking? You're asking what AC was.
No, OC
Oh,
or
OC.
OA and OC.
Oh. So I mean, I was.
Okay. What about OC and OA?
You can do it,
I
Jacob.
didn't say it.
Jacob, what are they?
You're the radius.
They're the radius of the circle, or they're the radii of the circle, right? And all radii of a circle are congruent. So that is the definition of radii. All right, we are getting close. Fewer people can speak now.
Banish it.
You can do it, William. I believe
So
you.
what is the next thing we want to say? So far we have AM and MC, we have OA and OC. So what else do we want to say?
You know, we got a O and an M.
Yeah, what about OM? What do those 3 dashes mean for OM?
Those 3 dashes, that it's like a congruency statement to the other side.
It's a congruent statement just to itself. OM and OM. That's why this reflexive property, right? It means it's congruent to itself. So segment OM is congruent to segment OM. And that is reflexive property of equality.
Oh, I was like, why are the equal sign?
Yeah. Reflexive property, I made it longer by drawing a bicep, and then I made it shorter by drawing an equal sign. Very nice. So now, because we have 3 sides of 2 triangles listed as congruent, Mia, we fall to you. What can we say about those 2 triangles now? They are congruent to each other. So if I were to say triangle AMO, what is that triangle congruent to? I have to list the sides or the vertices in the same order. So if it's AMO, so then I have to list this one, right? I did AM first, so on this one I need to do
Is it CM?
CM and then O. Very good. So to triangle CMO, right? Because order matters when we're talking about triangles. Now, why can I say that?
Your O's look like D's.
Thank you.
No,
Why can I say that?
No.
no, they.
Why can I say that these 2 triangles are congruent to each other?
Is everybody like that?
Everyone has spoken.
Let's go.
Okay, so it's because of SSS triangle congruence theorem.
Which stands for what?
Side.
Side, because I have 3 sides that are congruent, correct?
Am I re-exiled?
Yes.
Or Tayson.
Banished.
Theater kids.
You know, Romeo, I mean, if Romeo committed suicide, so.
No, stop.
Tayson, no.
Uncool. Okay, now because these 2 triangles are congruent, now I can say what we were trying to prove. So angle AOM
Congruent to angle con. Yep.
is congruent to angle COM.
Lexicon.
Why can I say that?
Oh, because of.
Yes, CPCTC. Corresponding parts of congruent triangles are congruent. You remember it by was it Moses? How did Moses part the Red Seas?
With paper towels.
He used some paper towels.
Yeah, that was-
That's theologically inaccurate, but it helps us to remember.
Well,
I
actually,
hope.
there is no proof that he did it.
Ooh, Elijah actually parted the Jordan.
Speaking of
Elijah-
the Bible.
Elijah parted the Jordan River with his cloak. He hid it. So that's like paper towels. Yes.
Can I interrupt for something very selfish?
Sure.
Jacob, what is the beginning of World Will Know? Like, when we start that scene, is it just Aiden on stage?
No, we're all on stage.
You're all on stage except Matthew.
Except Matthew, yeah.
So that's six guys on stage.
Yeah.
Yes,
Yes.
thank you. Okay.
Excellent.
Thank you, so sorry.
Sure, no problem. Okay. So now that we have those 2 angles are congruent, what can we say about the line OM?
What?
Because those 2 angles are congruent, this angle and this angle, what can we say about line OM, this green line, relative to angle AOC?
The angle bisector.
It is the angle bisector because it has cut that angle in 2. That's what we were trying to prove ultimately.
Oh no.
Nein, das ist schlecht. Das ist schlecht. Okay, so line OM bisects
That's segment. You need to add the little arrows on the end. There you go.
ray OM. Technically, it's ray OM. Bisects angle AOC. And that is by the definition of an angle bisector.
Thank you, friend.
Dot, dot, dot.
So one thing I will always remember is 3 dots.
Except for I said it poorly. I said dot, dot, dot. And that would be more like dot, dot, dot. But it's actually like dot, dot, dot. You know?
Dot.
No, I
Yes,
don't.
I do.
Dot, dot, dot. Anyway,
It's the height of the dot.
yes, that is the pitch. It corresponds with the pitch of my
Jason, what are your
voice.
thoughts on peach
So
and
dot,
black?
dot, dot.
Jack Black, not Blackjack. What?
Okay. Oh, that's it, yo.
Blackjack, but
Okay, so let me tell you right now, I'm going to give you a hint. Number 14. Notice L prime, M prime, and N prime. They really put the L in LM and M prime because they are not on endpoints of this coordinate plane. So what we need to do is you will actually have to draw this line segment. That ain't it. Draw the line segment from L to L prime, and then you will have to use a perpendicular, construct a perpendicular bisector using a compass. Okay? If you do not remember how to construct a perpendicular bisector,
I know how to construct them. Why were you looking at me during that? I feel targeted.
if you don't remember,
I know. I remember.
ask me.
yes.
Okay, that's all. Thanks.